Good morning, student. Today, in lecture number 5, I have topic circle and theorem first. There are two theorems of this chapter, circle, and we are taking the first very important theorem, and on the basis of this result, we will prove the next theorem also. Prove that the tangent at any point of a circle is perpendicular to the radius through the point of contact. You see, we have used 2 or 3 words. One is tangent to a circle, perpendicular, and point of contact. What are these? First of all, we have to try to understand what is tangent line. If we draw a circle, this is a circle. If we draw a circle, we require how many things? 2 things. One is center and some radius. So first of all, I am taking given as we just how to write in circle with the center O and radius R. We can write this, or we can say in place of this, or we can write or in circle C with the center O and radius R. In place of this completely we can write this. What is tangent line? Students, please see, this is a circle. This is center O. If we draw a line which touch, or we can say intersect at one and only one at one point of a circle, this is known as tangent line. And what is this? This is contact point. If a line which intersect this is known as secant line. I think you understood this. So what is tangent line? Tangent line, a line which touches at only one point, or you can say which intersect the circle at one and only one point. This point is known as contact point. So here also there is a tangent. So we are to draw, what is this? We are to draw a tangent. This is a tangent line we have taken. This is a P. P is the point of contact. We have taken this X and Y. XY is a line, is a tangent with the contact point P. OP is joined. We have joined OP. OP is joined. To prove, what we have to prove? What is said? Radius through the point of contact is perpendicular. This means we have to prove OP is perpendicular to XY. XY is the tangent. This OP is radius, center to this point. A circle is perpendicular to the radius through the point of contact. This tangent is perpendicular. We can say in another way, radius and tangent are perpendicular to each other at contact point. We have to prove this. Construction is there. We take another points. If I take A point on XY, or B, or here also you can say C. If we take this and join this, you see, we take points A, B and C on tangent XY other than point P. and join OA, OB and OC. You can take any points or you can take only one point even. There is no problem at all. You see my child, there is, what you will see, we have to take this. You see, what is this point? P point is lying on the circle or not? You can say because point P lie on circle and point A is outside the circle. Outside the circle. Clearly, from here, what you get? This OP is smaller than OA or not? You see this? This is a very important point I am telling you this. This OP, this distance from O to P and this distance from O to A, this OP is smaller than OA. Similarly, OP is the smallest, OP is smaller than OB or not? You can take it second. Similarly, OP is smaller than OC. This is third or not? From first, second and third, what is this? OP is smallest distance from O to any point on line, on tangent line XY. Here OP is the smallest distance, or as we know smallest distance is perpendicular distance. So this OP is the smallest distance from O to this line, and we know the smallest distance from anywhere. The smallest distance is perpendicular distance, so OP is perpendicular to XY. So students, you are to remember this result also in this way also. This radius and tangent are perpendicular to each other at contact point. They make always 90 degree. Again we have to see, there is, you understood what is tangent? Tangent is a line. In circle, we take a circle. There is a tangent XY. You can write this in circle with center O and radius are like this, or you can write in circle C with center O and radius are the same way. This with XY is a tangent with the contact point P. This is a contact point, and OP we join first. We have to prove this OP is perpendicular to XY. Then we take points A, B, C, D, or you can take only one point. There is no problem at all. And we join this OA, OB and OC. This you see here, P is a point on the circumference of this, on the circle it is there, and A is outside the circle. So clearly you will find this OP, the distance from O to P, is smaller than this distance OA. In the same way we can say OP is the smaller than OB, and OP is the smaller than OC. So from first, second and third, what we got, OP is the smallest distance from center O, you can say from center O to any point on tangent line XY. As we know, the smallest distance is perpendicular distance. Smallest distance, and this OP is the smallest distance from O to this line. So OP is perpendicular to this tangent line. So this was the theorem and of chapter circle, and this first theorem, and this will be used in the second theorem also. So I think you understood this. You try to, again I am repeating the result. The radius and tangent to a circle are perpendicular to each other at the contact point. Thank you from my side. Yeah, I think you have understood this.